Okay, in red we have some videos for section 4.4 here. A couple of proofs. Second one's a little more challenging than the first. In the first case, if you look to the left, I have three premises here that I've written in. Conclusion wound up going where I would write premise, but we can just briefly say premise, premise, and premise. Take a look at the premises here. We have, first of all, if not B, then C. Secondly, if A, then not B. Third, we have, if not A or C, then all of the following. Both not D and E, and U. Okay, so this involves some of the new rules here. Think about how you could proceed here, as always, based on our rules, both working forward, and working backwards, thinking about where you're going. In terms of the latter here, the consequent of line 3 of the third premise here is very similar to the conclusion, and if you take a look at it, it's really equivalent. It's logically equivalent to the conclusion. We have a string of AND claims in both cases, and the order of AND claims does not matter. Technically, it's going to involve both commutation and association, as we'll see here. In terms of transferring, once we get to the consequent of line 3, to the conclusion here. The way we begin here, or a sensible way to begin at this point with rules of equivalence, there's definitely more than one way you can do any given proof, at least if you want to make it longer and so on and so forth, and often very many unique, interesting, effective ways to do a given proof. Okay, I think most straightforwardly though we get if A then C from lines 1 and 2. That's hypothetical syllogism. Hopefully you saw. At this point, that doesn't really match with what we have before, but it's extremely similar to what we have as our antecedent in line 3. And as a matter of fact, we can just use our material implication rule to get there. Material implication, remember, if we have an if-then, that's the same thing. If x then y is the same thing as saying that either not x or y. If then means we don't have T horseshoe F, so we either have the antecedent false or the consequent true. That's a material implication rule. So I can just transform 4 into not A or C. It's material implication. Lines 4 are 5 rules of equivalence in this section. We'll always cite just one line number because they are simply replacing one equivalency within a given claim or line with another. That's how they work in the structure here. Now that I do that, I have modus ponens, lines 3 and 5, giving me not D and E, and parentheses and U. So we say modus ponens, lines 3 and 5. And then to complete this, see if you can do it here. Thinking about the rules of equivalence, we can go the following route. Not the only route, but we can do the following. First, we can change the parentheses. Change it to not D and E and U, like that. That is association. And we change the parentheses in a string of an and. It also works for an or claim, as was suggested before, since association on line 6. And then we can flip the two sides of an and, the main operator of and being the relevant and in this case, and that's going to give us exactly our conclusion. So we can say E and U and not D. That is a commutation where we flip the order. Association is where we change the parentheses. But in any case, we're talking about strings of ands and ors depending on the situation. It's commutation to line 7, and we're done. Okay, next proof. Take a look here, pause, see if you can solve it. And if you can't anticipate what I'm going to do, stop and pause and go along those lines so you can learn, practice solving these problems yourself. Okay, in this case, we want to take a look at what we're trying to prove. Works somewhat similarly in its very basic skeleton to the previous problem. The consequent of line 1, if you take a look, is turns out to be equivalent to the conclusion that we're trying to prove. If D, then if E then X. These are equivalent via the exportation rule. And I talked about how that works before, but if D, let's look at this, the consequent of line 1. If you have both D and E, you get X. Another way of saying that is if you have D, then if you have E, you'll get X. That's how that goes here. So if we can get to the antecedent of line 1, we're going to be home free. And some of it's straightforward, working forward, and part of it's absolutely not, I would say anyway. First thing we can do here, if you look at lines 3 and 4, you probably see a disjunctive syllogism. Hopefully you do, but it's not technically a disjunctive syllogism until we change the order of line 4. So we should first say C or not B, and that's a commutation of line 4, setting up to have the exact form of disjunctive syllogism. Remember, disjunctive syllogism says P or Q, not P, getting you Q. Technically speaking, it does not say P or Q, not Q, therefore you get P. That's fully valid, but it's not disjunctive syllogism. Okay, technically speaking, and this is a technical formal enterprise. All right. Proceeding at this point, then we have our disjunctive syllogism giving us not B. That's DS, or disjunctive syllogism, lines 3 and 5. Okay. And then again, going forward, you might have noticed, hopefully you've noticed, that we have basic modus tollens with lines 2 and 6 giving us not A. So we say it. That was lines 2 and 6. All right. Now is where you probably get stuck, or at least a greater chance you would get stuck. You got to show some creativity here. Here's how we do it. We go not A or not D. That's an addition on line 7. I did that because I can now get to the antecedent of line 1 using De Morgan's. If I have not A or not D, that's the same thing as saying it's not the case that both A and D. That's one of the equivalencies of De Morgan's law, or theorem. And now we're about home. Now we got the modus ponens lines 1 and 9. D and E applies X. Modus ponens 1 and 9, we said. And that's how it goes. And then we just use exportation, we're done. That's also the same as saying if D, then if E, then X. It's exportation on line 10. And that's a couple proofs.